All right, so here we go. Geometry. We love this stuff. Classifying quadrilaterals. So first, if we're going to classify quadrilaterals, we have to know some basics first. A polygon is a simple, flat, closed figure formed by segments. Poly means many. So polygon is a many-sided shape. These are all shapes that are not polygons because they don't fit one of the descriptors up here. So this first one is not made of segments. You'll notice there are curves. We do not have curves in polygons. This one is not simple. So what do we think simple means? Simple means that there are no intersecting segments. All right, and this one is not closed. So if you follow this shape around, you never get back to the beginning. A closed shape would just continue around like in a loop. So it means that all of the segments connect at vertices. And vertices, fancy word for corners. So you will notice that these close at a corner, these close at a corner, these close at a corner, but this one does not close at a corner. So we have some examples on the right here of things that are polygons. These two are called convex polygons, and the next two are called concave polygons. So convex polygons, all of the vertices are sort of pointing out, whereas on a concave polygon, we have at least one vertex that is sort of pointing in. Now, there's a really formal definition for it, that one or more vertices has caved in, not very formal. But when you talk about convex polygons, all of the diagonals stay inside the shape. If you are talking about ones that are concave, then if you try to connect, there's at least one diagonal that's outside of the shape when you're connecting vertices. So fancy term for it is that the diagonals stay inside the shape on convex and that at least one diagonal is outside on concave. We can also say that on concave, one or more vertices has caved in, right? And that's sort of a mnemonic device. If we want convex, we would say no concave vertices. A regular polygon has segments that are all the same length and all the angles are the same measure. So some regular polygons that we're familiar with: square, all four angles, right angles, all four sides the same length. Another one that we're really familiar with would be equilateral triangle. So if we look down, we've got a list of different types of polygons. And those different types of polygons are named based on the amount of sides. So a triangle has 3 sides, a quadrilateral has 4 sides. This is all about prefixes. And if we can remember what the prefix means, it's really easy to remember the number of sides. So if we want to sketch one of these polygons, for example, a regular hexagon, we'd have to know that a hexagon has 6 sides, and we'd want to sketch something where all 6 sides are the same and all 6 angles are the same. Now, mine is not perfect by any means because I can actually tell some of my sides are a little longer than others, but I can put single tick marks on all of them, telling the person looking at my design that I intended for all 6 sides to be the same. I would also then put a single arc on all of the vertices, signifying that I intended for all 6 angles to be the same. So while it is not drawn perfectly as a regular hexagon, I can tell from the symbols that it was intended to be a regular hexagon. Now, if I'm going to sketch one that is not regular, the only thing I have to do is take away one of those 2 qualities. I mean, I can make a hexagon that's all kinds of messy. 1, 2, 3, 4, 5, 6. That's a hexagon that's not regular. It also happens to be concave. So this would be a concave irregular hexagon. But you can also just do something like 1, 2, 3, 4, 5, 6. Now I've got, 4 sides congruent. The other 2 sides are congruent, but not all 6 sides are congruent. So this would be a hexagon because it has 6 sides, but it's not a regular hexagon. If we look at the back, we have all of the different quadrilaterals that we are expecting you to know and be familiar with. Now, quadrilateral means the only way to fit into this category is to have 4 sides. If they have certain qualities, then they get special names. So, for example, the rectangle has to have two pairs of sides that are parallel. Now, parallel are those little arrowheads. And you'll notice down here, we've got the definition for parallel: lying in the same plane, but never meeting, no matter how far extended. Parallel means they're never going to touch, okay? So if two sides are parallel, they always stay the same distance apart, and we use matching numbers of arrowheads. Congruent are the little tick marks. So if they have the same amount of tick marks, then we know they're the same length. So you'll notice the two sides I just colored pink happen to have the arrowheads and the tick marks. They're congruent and they're parallel. On the other side, you will notice I have a single arrowhead and a single arrowhead because those sides are parallel to each other, but not the previous side. They also have the double tick marks because they're congruent to each other, but not the other side. So parallelograms, two pairs of parallel sides, you'll notice the arrowheads have, two that match on the top and bottom, two that match on the sides. They've also got the tick marks that are the same as a rectangle. The only thing that's different is the rectangle requires the 90-degree angles, while the parallelogram does not. It kind of looks like a rectangle that's tipped over. You've also got a square. Square has the pairs of parallel sides, right? Top and bottom parallel, left and right parallel, but it's got all four sides congruent. That means they all have the same one tick mark, and they have right angles, where the rhombus sort of looks like a square that started to tip over. It's got the matching parallel sides on the top and the bottom, the parallel sides on the left and the right, all four sides with the single tick mark, so they're congruent, but it doesn't have the right angles. So you usually see that rectangles and parallelograms kind of travel together. Squares and rhombus, or plural rhombi, travel together. We have a couple that are unique. Kites are really unique because the sides that are congruent are adjacent, and they're the only shape that require adjacent pairs of congruent sides. So those two sides at the bottom are the same length, and these two sides at the top are the same length, but not all four. Trapezoids have bases that are parallel. So they have two sides that are opposite and parallel, but that's it. The other two sides don't have to be, and they shouldn't. On this one, it's the top and the bottom that are parallel. Now, this one happens to have right angles, not required. This one happens to have congruent sides on the left and the right, not required. That one gets a special name. This one's actually called an isosceles trapezoid, and this one's called a right trapezoid because it has other special qualities, but their base shape is a trapezoid because it has that single pair of parallel sides. Other quadrilaterals is your last one, and that means that it's got four sides and none of the other special qualities. So no pairs of parallel, no pairs of congruent, nothing else really special to make them stand out. The last symbol that I hadn't talked about was the little square in the corner, and that's for anything that has a right angle, 90 degrees. It gets that little square in the corner so that we don't have to write 90 degrees, which is awesome. Last but not least, at the bottom, you'll see that I have all of the definitions for the different shapes. These are also on your printed hard copies. So a rectangle has two pairs of opposite, congruent, and parallel sides, and all the angles are 90 degrees. Parallelogram has all of the same stuff, not the 90 degrees required. Square, opposite, congruent, parallel sides, and by congruent on a square, we're talking about all four sides congruent and all four angles congruent at 90 degrees. Rhombus has all the same qualities, does not require the 90 degrees though. Kite, two pairs of adjacent next to each other, sides that are congruent, and trapezoid has that exactly one pair of parallel sides. So the trapezoid was the one that was kind of quirky because only one pair are parallel and the other ones could be short, long, same, different. Doesn't have to be top and bottom, doesn't have to be left and right. The one that I have drawn over here, this is my kite, where I've got two sides that are adjacent next to each other and congruent. The other two sides are next to each other and congruent, but not all four. And they're not opposite.